All right, today's lesson is going to be on solving proportion problems with ratio tables. Just a reminder, when you're watching this video, if at any time you need to, pause it and rewind or hear something over again, please feel free to do that as you're going through here. All right, so to get started, it says the cost of 5 cans of fruit juice is $10.20. So the first question here is, how can you find the cost of 1 can of fruit juice? Okay, and then what is the cost of 1 can of fruit juice? Well, I can use, I know that 5 cans are $10.20. I know that 10 cans are $20.40. I could use either one of those and write a ratio. I'm going to choose the the 5 cans over the $10.20. Okay, just because it's smaller numbers are easier to work with. Okay, if I want to know how much 1 can of fruit juice is going to cost, well, in my ratio here, cans are on top, so that 1 can has got to go on top, and I'm looking for that. So I can do my cross multiplication here. $10.20 times 1 is $10.20, and 5 times x is 5x. The opposite of multiplying by 5 is dividing by 5. My 5's cancel. I am left with the $10.20 divided by 5, which comes out to $2.04. Okay, so that 1 can is going to cost us $2.04. Okay, how can you find the cost of 31 cans? Okay, what's the cost of 31 cans? Well, there's 2 ways we can look at this. Again, we can do the 5 cans over $10.20. We can use that ratio. And again, we know we got 31 cans. We put that on top. And we're looking for this. Okay? So I know that 5 times x is going to be 5x. $10.20 times 31. Okay, I'm just going to go ahead and see what that is. So $10.20 times 31 is $316.20. And then I'm going to go ahead and divide that by 5. Okay, so on my calculator, I can just do divided by 5. And we get $63.24. Okay, so we know that 31 cans is going to cost us $63.24. Okay, or the other way, and this is going to seem really simple, is since we know the cost of 1 can is $2.04, we could just take the $2.04 times 31, and you would also get the $63.24. So again, $2.04 times 31, you also get the $63.24. Okay, so both ways would work there. All right, moving on. We have 2 tables here, and we need to decide if they're a proportional relationship or not, and how we can tell. Well, in the first one, the top table here, I'm looking at the first one is quantity A to quantity B. All right, sorry for the delay there. So quantity A over quantity B, if I look at the first one, that's 2 over 5. If I look at that 4 over 10, if I simplify that, that's going to simplify to 2 over 5. If I look at the 7 over 17.5, okay, now the decimal one makes it a little tricky here, but 3.5, okay, if I take 7 divided by 3.5, that's 2. If I take 17.5 divided by 3.5, that's also 2 over 5. Okay? And then 10 over 25, that's also going to simplify. 5 goes into 10 twice, 5 goes into 25 5 times. They all simplify to the same fraction. Okay, now another thing you could do is if I took A over B here and I just divided those, okay, I'll go to the calculator here, but if I take 2 divided by 5, I get 0.4. If I take 4 divided by 10, I get 0.4. Again, this works for all of them. 17.5, 7 divided by 17.5, I get 0.4. 10 divided by 25, I get 0.4. So to answer the question, is this a proportional relationship? The answer is yes, it is. Okay. Now for the next one, is this one a proportional relationship, and how can we tell? Well, our first one is 5 over 3, if I take A over B. Okay, but if I take 10 over 8, that is going to simplify. They're both even. 10 divided by 2 is 5, but 8 divided by 2 is 4. So they do not simplify to the same thing. So right there it tells me that the answer to this one is no. Okay, and the reason is because the ratios are not constant. Okay, and again, if you went to your calculator and tried them and did 5 divided by 3, you get 1.6 repeating. If I do 10 divided by 8, I get 1.25, so they're different. That's the other way to tell that they are not proportional. Okay, next here, just a couple examples. Again, definition of a proportional relationship is there. When the ratio between two varying quantities is constant, the relationship is called a proportional relationship. Okay, so that's basically what this is all about. The example 2 here is with the juice can. Again, you can see another way of thinking about this. If you want to pause and take a look at that, go ahead. Now for some work here. So Mrs. Seebeck, the art teacher at Monroe High School, wanted to purchase a new paintbrush. For each of her 32 students, the art store offers brushes in packs of 4. Each pack of 4 brushes sells for $17. So she asked her students to calculate the total price of the brushes. Jamal made the following ratio table to solve the problem. Describe what steps he used. Okay, so he started out with 4 over 17. Then he went 8 over 34, 16 over 68, 32 over 136. Okay? So what Jamal kept doing here is he just, to get from one to the other, he just kept multiplying by 2. Okay? And if you look at the bottom, same thing. He just kept multiplying by 2. All right? Okay, then the next table here, you had Rosa. And we need to describe what steps she used. Well, to get from 4 to 32, what she did was multiply by 8. And if you take 17 times 8, you'll also get 136. So all Rosa did, she just multiplied 4 and 17 by 8. All right, so there's what Jamal and Rosa did on this table. Moving to the next one here, it says Lisa made the following ratio table to solve the problem. Okay, it says identify where Lisa made a mistake and write the correct numbers. Okay, so she said 4 brushes cost $17. She used that to determine that 1 brush was $4.25. Okay? And then she kept going to make it. Where her mistake is for the 32 brushes. So the way we can check that is they told us that it's $17 for 4 brushes. Okay, if you take 17 divided by 4, that comes out to the $4.25 for 1 brush. So if I wanted to know how many 32 or how much 32 brushes cost, I would just take that $4.25 times 32. Well, when we take the $4.25 and multiply that by 32, we get 136, not 129.50. So it should have come out to $136 for that. So B, it says write advice for Lisa so she will not make the same mistake next time. So we're going to tell Lisa if she's going to add, she would need to add the price of 2 brushes to the price of 30 brushes. Okay, and that's not what she did. So what Lisa could have done is, set up a proportion using the given information. So we know that 4 brushes cost $17, and we know that would equal 32 brushes over the cost of 32 brushes. Could have did the cross multiplication and figured that out. Okay, number 3, use a ratio table to find the number of paintbrushes Mrs. Seamet could buy for $238. Okay, so again, we know it's 4 brushes for $17. We know we have the $238. We're looking for the number of brushes. So 17 times x is 17x. 4 times 238 is 952. And again, we just have to divide by 17 there. 17's cancel. So we get x equals what 952 divided by 17 is, which is 56. So it would be 56 brushes that she could buy for the $238. Okay, number 4, decide whether each of the following tables is a ratio table. Explain why or why not. All right, so if we look at the first table there, A, that one is a no. 4 over 12 will simplify to 1/3, but as soon as I check the next one, 8 over 30, that one only simplifies to 4/15. So it only takes 2 of them to not be constant to say no. If you look at B, that one is a yes, because what happens is, if I take A over B, and then I take 4A over 4B, well, the 4's cancel each other out, so you're left with A over B. It simplifies to the same thing. Same thing with the 16A over 16B. The 16's cancel each other out, and again, it simplifies to A over B. Number 5, in your own words there, describe what it means for 2 quantities to be in proportion. Well, what it means to me is the ratio is constant. If you take the first quantity divided by the second quantity, you should get the same thing for every column in your table. That's what it means for it to be constant. If that's not the case, then they are not in proportion. Okay, to close out here, how can you determine if quantities in a table are a proportion? So the answer to that question is, if the ratios are equal, it's a proportion. Okay, go ahead and finish up what you need to here and show it to staff member in the room.